We are given the equation of a curve y equals x to the negative 2 over 3 ln x for positive x. This curve has one stationary point. And part A, find the exact coordinates of the stationary point. Stationary point occurs when the derivative dy dx is 0. So we need to find dy dx. Since x is the product of two functions, we have to use the product rule. We keep the first term, x to the negative 2 over 3, differentiate ln x, that will give us 1 over x, plus ln x. Now we differentiate the first term, we have negative 2 over 3, x to the negative 5 over 3. From this part here, x to the negative 2 over 3 times 1 over x, that is x to the negative 5 over 3. Then this part is negative 2 over 3, x to the negative 5 over 3 ln x. We can factor out x to the negative 5 over 3, and we have 1 minus 2 over 3 ln x. This can actually be written as 1 over x to the 5 over 3 times 1 minus 2 over 3 ln x. X to the 5 over 3 is in the denominator. To find the stationary point, we need to set dy dx to 0. Denominator cannot be 0. At any rate, x must be positive. Then we are left with 1 minus 2 thirds ln x equals 0. We need to solve for x. Rearranging, we have 2 thirds ln x equals 1, or ln x equals 3 over 2. Then, taking anti-log, we have x equals e to the 3 over 2. This is the x coordinate of the stationary point. To find the y coordinate of the stationary point, we sub x equals e to the 3 over 2 into the function, so that y is e to the 3 over 2. This is raised to the negative 2 over 3, and we have ln e to the 3 over 2. This will give us e to the negative 1, and ln e to the 3 over 2 is just 3 over 2, which can be written as 3 over 2e. Then the stationary point has exact coordinates e to the 3 over 2 and 3 over 2e. This will give us the stationary point. Part B, you need to show that the definite integral of y dx is 18 ln 2 minus 9. Y is x to the negative 2 thirds ln x. We have the product of two different types of function. To find the integral, we use integration by parts. So we let u to be ln x. Then dv must be x to the negative 2 over 3 dx. When u is ln x, du dx is 1 over x, and du is 1 over x dx. So to find v, we just integrate x to the negative 2 over 3 with respect to x, and that will give us plus 1. We have x to the 1 over 3 divided by 1 over 3. So that will give us 3x to the 1/3 for v. Integration by parts, you have u dv. This is uv minus the integral of v du. So from a to b, we just evaluate from a to b. And in this case, u is ln x, v is 3x to the 1/3. We have uv here, 3x to the 1/3, and ln x from 1 to 8. And then we need to integrate v du. So we have 3x to the 1/3. Du is 1/x dx. We keep the first term. And for the second term, let's see x to the 1/3 divided by x. That will give us 3x to the -2/3. So we have this. And to integrate that, 3x to the -2/3. Then we have 3, and this part here, x to the 1/3 divided by 1/3 here. So that will give us 9x to the 1/3. Then we have 9x to the 1/3 from 1 to 8. Now we evaluate. So we have 3, 8 to the 1/3 ln 8 minus 3. 1 to the 1/3 is 1, and we have ln 1 minus 9 times 8 to the 1/3 minus 9 times 1. 8 to the 1/3 is 2. This is 2. That is also 2. So we have 6 ln 8. Ln 1 is always 0. We forget about this term. Subtract 9 times 2, we subtract 18. This is 9. The 2 negative will give us a positive. So we have 6 ln 8, but what you are asked to show is ln 2. 8 is 2 to the 3. This 2 will be minus 9. Then using the power law, ln 2 to the 3 is 3 ln 2. 3 times 6 is 18. Ln 2 minus 9.